Welcome to another video from Lockdown Electronics with me, Bill, and this time we've got a review of a signal generator, and it's the Junctek JDS8080. Now Junctek, the manufacturers, contacted me and asked me if I would like to review this. They've put no preconditions on that, they've just sent me an instrument to try out. So I'm going to give you my honest opinion, show exactly what I get, and for the most part this video is going to be filmed as I'm actually exploring what's going on too. So I'm particularly keen to look at this because this signal generator actually goes to 80 megahertz and also includes Bluetooth functionality, which apparently allows it to connect to mobile phone apps, so we'll have a look at that too. Let's start then by looking at the outside of the case and the connections. Looking around the outside of the instrument, then we've got the plastic fold-up stand there if you want to use it on the bench, give you a slightly better viewing angle. As an instrument, yeah, it's plastic and it's quite light, so there isn't a lot of weight to it, but it does feel reasonably solid and strong. I mean, I'd be quite happy with that sitting there amongst my other kit. So we've got the various connections. The on-off switch there is a soft on-off switch. On the rear, where the mains lead comes in, there is a hard on-off switch. I'd prefer a hard on-off switch altogether, but a lot of instruments don't have that. Even my Siglent Spectrum Analyser has that soft on-off switch, and I tend to switch the entire bench off when I'm not using stuff. So various buttons with functions, rotary encoder here, which has also got a push button, and 4 sockets on the front, 2 sockets on the rear, sync in and out. We've also got the TTL, which repeats some of that, a USB in. You can run it off DC 5 volts, and there's an earth connection there, and I'll come back to that in a moment. It does explain to you what the various connections there are on the TTL, which is quite useful. Okay, so one thing which often comes up is, are the outside of the BNC connectors here connected to mains earth? So I've got a meter here with set to continuity. So what we'll do is we'll actually try that. So I'm just going to put the connector onto the earth pin. I can just about manage that, and there is no continuity. So in terms of mains earth, there's no connection between the mains in earth and those connectors, so that's something to be aware of. There is, however, on the back a screw connection for ground, it says there. So if we pop the meter onto that connection, I would expect this to have continuity, which indeed it does. We'll just check it's got continuity with the back ones as well. I'm sure it has, if that's the case. Yeah. So would imagine it wouldn't be difficult to add an internal connection in there to make sure it was earth to the mains. If it's attached directly to my oscilloscope, it will be connected to, those will be connected to mains earth, but just be aware that there may be some voltage floating on those potentially because they're not connected to earth. That's just something to be aware of. So that's the outside of the box. You also get a BNC to BNC lead. You get 2 BNC to crocodile clip leads. You get a USB cable to connect to a PC, and your standard mains lead, obviously with the plug on, depending on what part of the world you're in. So that's the outside of the box. Let's now get it plugged in and see what she does. Okay, so I've got the mains attached to the back. I've switched the hard main switch to on, and a press of the button results in displaying the logo and fairly quick boot up into the menu, showing the 2 output channels there, and currently they're both enabled. You can switch those off. Now I turned off the beep when I tried this out a few minutes ago, but because I've had the mains switched off, it doesn't remember it over the mains. So if I just pop into system there, and I can just go down to sound and turn it off. and if you leave it plugged in with the mains, then yeah, that's fine. Another way to do that is to pour some super glue into the into the buzzer. That would cure it too. I jest, but yeah, the sound, yeah, potentially handy in a noisy environment, but not really my kind of thing. So pressing system again puts us back to the menu. Okay, let's now get it connected up to the oscilloscope and see what she'll do. Okay, let's start by taking a look at bandwidth, and I did mention in the intro that I was particularly keen to try this out because its specification is up to 80 megahertz, and my current signal generator only goes up to 30 megahertz, which is fine for most of the time, but just occasionally be quite handy to have that bit extra. So I've got the machine attached to my Siglent scope, which is 100 megahertz bandwidth, and there is a previous video, I'll put a link up top to that, which I did actually measure the bandwidth, or attempt to measure the bandwidth using the rise time method, and I get a result of I think it's over 120 megahertz for the 3 dB down point for this this particular Siglent scope. So I'm at least 40 megahertz, possibly more, inside its ability to measure. So I've got a detached BNC cable and a 50 ohm load there, just to hopefully match it up. The stated output impedance of the signal generator is 50 ohms. I think it's 50 ohms plus or minus 10%, I think, off the top of my head. So currently I've got it set to 1 megahertz and 3 volts peak to peak. Right at the top end of the spec, it does about 3.6 volts peak to peak. It'll do more lower down, which is fairly common. And what I've done here is I've measured the voltage on the scope, and I've put a cursor on. You can ignore the bottom cursor, but this cursor here, I've positioned that at what effectively is the 3 dB down point. So if at any point as we increase the frequency, the top of that waveform drops below that line, we know it's gone below the 3 dB point, which is what most folk accept as being reasonable from a bandwidth point of view. So I'm going to start going up in 1 megahertz, and fairly quickly we reach a point where the display is a bit meaningless, so I'll just adjust the time base so that you can still see some waveforms. We'll keep on going. We're up at 30, well, that's 30 megahertz, and if I keep on going up to 40, as you can see, we're still well inside that. There's 50, 60, and as I approach 70 megahertz, it's still pretty much the same as the original 1 megahertz, which is quite good. And as we start to go up now, you can see it is dropping, and that's 80 megahertz, and we're still well inside the 3 dB down point. So it certainly does produce a reliable looking sine wave up at 80 megahertz, which I'm quite pleased about. So in terms of changing things, the interface is very straightforward. It's incredibly similar to the Feely-Lek and one or two of the other signal generators, where you've got you choose which mode you want. I've got in frequency here, but that's amplitude, and I can adjust down the amplitude there if I so desired. Go back up to 3 there. There's offset, there's duty cycle, and there's phase. Obviously, if you've got 2 channels outputting, you can adjust the phase between the 2 channels, which might be useful for measurements. Dropping back into frequency, the cursor lights up, and using the left and right buttons you can position exactly where you want to be. So I could, if I wanted to, here step down in 10 megahertz increments, so I'm down to 20 megahertz there. Let's just tweak up the time base a bit so you can still see some waves, and down to 10 megahertz there. And if I go beyond that, it actually switches off, so I'd need to move to the next significant digit, and then I can drop down through 4 through to 1 megahertz again there. So it's possible to make extremely small adjustments. So for instance, if I move there to the ones units, I can actually alter the frequency by 1 Hertz, which is well beyond the measurement ability of, there you go, at 1.005, so 5 Hertz above the scope is saying 1 megahertz. So we're certainly very, very close in terms of measurement accuracy. Can't guarantee you that my scope is bang on, but certainly more than adequate for hobby electronics and probably other things as well. The second channel is exactly the same, so I won't bore you with going through that, but what we'll now do is we'll now get set up and look at a few different waveforms. Okay, looking at the waveforms then, if we press the wave display, we've got a quick access menu here that we can get to some of the waveforms with, but once we've pressed wave we can also step through using the rotary encoder. So there is square wave, there's a little bit of ringing just at the top of the wave there, and also at the bottom. That may be partly the setup and perhaps the quality of this cable. So we've got square wave, we've got triangle, ramp, all that's a CMOS one. That's potentially quite handy. That's certainly something I would use, as it gives me saves me having to set up a square wave, which is exactly the right voltage if I want to be say putting some pulses into some CMOS circuitry. You can also have a DC output there, which is also potentially quite handy for making measurements, and then we've got all the usual suspects: half wave, full wave. Won't bore you with it. There's noise there, exponential, fall, rise, various bits and pieces, but they're all there. And there's also a number of programmable waves that you can put in using the PC software. So those are the waveforms, and there's also all the various settings in there, nice and easy to get to. If we move to modulation now, in actual fact, before I do that, I'm going to go back to sine wave. So I've got a 1 megahertz signal there on channel 1. So if I go to modulation, currently we're set to AM 50%, and we've got a 10 kilohertz modulation tone there, and hopefully you can see that. If I adjust you should be able to see the envelope. Yeah, there you go. So there's your classic AM modulation envelope, and then if we go down to well, we can adjust the frequency as well, quite obviously, which is potentially quite handy. Also the depth and the type of modulation there. So that's AM, and we've got FM. Clearly not going to see much there, but if we now, oh yeah, they can also set the deviation on FM, which is quite nice. You've got pulse width, various shift keying modes, PWM, burst, etc. Certainly for me, the AM and the FM with my interest in radio is going to be the two that I'll make use of the most. One thing that is quite nice actually is you can actually feed modulation in here. So if you wanted an externally modulating signal, you could certainly have one. This does appear to have, plenty of opportunities to create an internally modulated signal, so I wouldn't be too concerned about that. But yeah, so that's modulation, and then turn modulation off. Let's just make that display look usable again. There we go. So we've got sweep and start frequency, stop frequency, time, direction and sweep mode, so you can have line, you can have rising, falling, etc. So if I just switch that on, that's at quite a low frequency, so I doubt very much that's even going to be, there we go, that's better. So that's the sweep as it starts up. Certainly that's something I would make use of around about 450 kilohertz to be able to sweep across the IF filters of a radio. And it's not for this video. I'll do another video on it, but certainly that's potentially quite a useful function of the sweep, and I think it'll be worth trying to see if we can get it to work with the scope and produce a kind of bode plot. I think that's going to be possible, as there is a synchro output on the back. Okay, let's now get it hooked up to the spectrum analyzer and look what the harmonics are like. Okay, looking at the harmonics then. So I've got the signal generator producing 1 megahertz to about 300 millivolts, so I don't overload my spectrum analyzer too much. I've put a marker on the fundamental there, and I've put a second marker on to the second harmonic, and according to the display here, we've at about minus 44 dB for the second harmonic, and if I can scroll across to the third harmonic, just be nice and steady there, and the third harmonic's about, well, it's jumping about, but it's probably about 57, 58 dB down on the fundamental. This is for the sine wave. Now if I just pop onto square wave, as you might expect, we suddenly get lots and lots of harmonics on the square wave, as you would expect. That's back to the sine again. So if I just turn off those markers, and then we'll just go to a bit more of a display. Let's now make the end of the display, let's now make that 80 megahertz. So that's the full width. So you can see harmonics tailing off there. But if I go on to square wave, as you can see, we get a rich set of harmonics with the square wave. As you would expect, that's not the fault of the generator. That's the sharp corners on the square wave, if you're familiar, which is producing those harmonics. And of course, they're not all bad, because if we now pick a frequency of, let's say, if I can do this relatively easily, let's go to 75. Let's go to 70. Let's go to 72.5. So that's 72.5 megahertz. Okay, as you can see there. And now what I'm going to do is just adjust the display again. So we'll make the start frequency 60 megahertz, and we'll make the stop frequency 250 megahertz, and so you can see we've got, in fact the third harmonic's actually quite high there. So if you're thinking, oh well, that's not very good, well no, it's not ideal, but it's very handy if you want to produce a signal inside the 2 meter ammeter band, which is where that'll be, and that's third harmonic's going to be in the 70 centimeter ammeter band. So certainly, potentially, for producing, for making use of the harmonics to look at higher frequencies than the machine is normally capable of displaying. If we just make the stop frequency 1 gigahertz, let's see where it starts to tail off. Give the display a chance to catch up. There we go. So yeah, harmonics up there right into about 500 megahertz, and there's still a couple there which are but let's just make sure that they are harmonics. Let's turn off the channel. It takes a moment for the scope to catch up, because I've got a relatively small bandwidth, so you can look at the detail. Yeah, there's just a little bit that'll be receiving just spurious. So we've got a frequency of 72.5 megahertz, so let's make the center frequency 72.5 megahertz. Give it a chance to catch up, and let's make the span 1 megahertz, so we can have a look at the waveform. And then what we can now do is we can now zoom in and have a look at that that wave, and yes, seems to be doing producing quite a nice little waveform there. While we're on that display, let's now pop into modulation, and that's AM with 10 kilohertz. So if we just increase the bandwidth a little bit, you can hopefully start to see some side bands on there. Yeah, you can do. So there's the side bands either side of the signal, and if I go back to non-modulated, switch between the two, you can see the effect of the modulation there. Okay, just while I've got it attached to the spectrum analyzer, there is another feature that this machine has. Obviously, like a lot of these machines, you can connect it to a PC and you can control it from a PC, but this machine has Bluetooth built in. There is an app. There it is running on my Android phone. There's also a version for the Apple phone, and this gives you effectively full control of the instrument via Bluetooth. Now, I'm not a great fan of using phones for everything, a bit old-fashioned in that respect. I quite like using the knobs and the controls, but I can see this is potentially very useful. You can have the machine sitting up there on the bench connected, and you can have this in full view, perhaps next to your meter. So I've currently got this in what's called primary mode. If I tap step, puts it straight into the step, or into measure mode, and you can see that the, well, hopefully you can see it reasonably well, that the machine is tracking exactly what's going on with the app. And here on the app, I can then make adjustments. I'm adjusting the amplitude there, but if I tap up there, I can adjust the frequency. Appreciate you can't see it, but the spectrum analyzer display is hopping us about as I change the frequency, and you can obviously change the waveform as well, and you've got channel 2 down at the bottom there. So you've effectively got all the settings on here. So I'm just going to get set up to use the measurement function, because that's one of the major functions we've not looked at. So we'll just get set up for that and see how the app copes with that. Okay, so I've got output from another signal generator connected to the external input jack here, and I've still got it connected via Bluetooth to my mobile phone app. So I'm going to switch on the output of the signal generator. We're currently saying 0, and give the gate time to calculate. So it's saying just 5 hertz above 1 megahertz. Now the signal generator fusion has only just been switched on, but that 5 hertz discrepancy is probably consistent with what we were seeing on the scope. So if I go up to say 10 megahertz there, you can see the display has changed to 10, and it won't be so easy to see on here, but the result is indeed being displayed on the app. And one other thing that the app is potentially quite useful for is if you wanted to grab some measurements. Obviously on the Android phone, a long press of 2 of the buttons gives you a screen grab, so you could it's a quick and dirty way of recording some information to make use of later, should you so desire. So I'll just go up to 20 megahertz. Yeah, and again showing 20, and I'll go up as high as I can on this one, which is 30 megahertz, and again, yeah, that's showing what we might expect. So that's measurement mode. Now I'm acutely aware that there's a load of other stuff on here which we've not looked at, and certainly probably requires another video. So maybe we'll look at doing at least 1, possibly 2 more videos on some of the functions, so you can see how it is. But I don't want to flood you out with Junctek signal generator videos, so it'll be a week or 2 before I do that. Yeah, so if we hop back to primary, you see it jumps straight back to the primary display there. So the app's very responsive, and it was extremely easy to connect to it on Bluetooth. You simply search for it and it came up straight away, and press connect and I was instantly connect. So I'm quite impressed with how slick the app actually is, and again, there is computer software for this, so I need to at some point have a look at that too, so that's potentially another video. And we've also got all the various settings here, including things like you can actually go into firmware upgrade. Now I've not looked at how we do all this, but hopefully you've got a general idea of how handy the app is for taking control of the machine. Okay, well that's it for a first look at the Junctek JDS8080 signal generator. I rather like it. As budget signal generators go, it's got quite a nice feel to it, and specification seems pretty good. The manual that's with it I've not mentioned, but it's actually quite readable. It's certainly understandable if you take a moment or two to just work your way through it. There isn't a particular specification in there. There is link to some online information, and I will include that in the description below so you can take a look for yourself. As this came from the manufacturer, I don't have any links to actually purchasing one. I found it on AliExpress, and you can find it there. I've also found it on eBay, so if I can find some links, I'll put those on for you too. But all in all, I'm quite impressed with that, and it's unfinished business. I can think of at least 2 aspects of this machine that I want to have a look at a little bit further, so I will do some more videos on that in the not too distant future. Thanks very much for watching. Hope you've enjoyed it, and look forward to seeing you on the next video.